Today, we have a fascinating topic to explore: the unique survival mechanisms of different plants. In this video, we'll delve into the mechanism behind plant survival and technology that can be beneficial for today's climate change. So, our first plant is Erodium cicutarium, which is also known as the common stork's bill. It is a small flowering plant native to the Mediterranean region, has evolved a remarkable adaptation to ensure the successful propagation of its species. One of its most intriguing features is its unique self-burying seed mechanism. In grasslands and open fields, Erodium cicutarium displays its extraordinary self-burying seed mechanism. As the seed pods ripen, they dry out, causing them to twist and coil, creating tension within the pod. When the time is right, the tension in the seed pods reaches its peak, and they explode open. The force of the explosion propels the seeds away from the parent plant, increasing their chances of dispersal. Erodium cicutarium seeds possess a remarkable adaptation that enables them to bury themselves in the soil. At the heart of this mechanism are specialized structures known as awns. Awns are elongated, bristle-like appendages attached to the outer coating of the seed. These awns play a crucial role in responding to environmental cues, particularly changes in humidity. They possess an exceptional sensitivity to moisture levels, which triggers their remarkable behavior. Here's where the magic happens. The seeds of Erodium cicutarium have unique self-burying mechanism to adapting in arid climates. When Erodium cicutarium seeds are exposed to dry conditions, the awns extend outward, resulting in a distinctive corkscrew-like shape. This elongation is an inherent response to prevent immediate germination and promote seed dispersal instead. However, as moisture levels increase, such as during rainfall or irrigation, a fascinating transformation takes place. As the awns begins to unwind, its twisting tail connects with the ground and causes the seed carrier to push itself upright. Then, as it continues to unwind, it creates torque to drill down into the soil and bury the seed. Once the seeds are nestled in the soil, they absorb moisture and begin to germinate, sending their roots deep into the ground. As the plant grows, it rewards us with its beautiful pink flowers, attracting pollinators and continuing the cycle of life. But the one-tailed version found in nature only work well in soils with crevices, so the scientists designed their e-seed version with 3, enhancing its ability to push itself upright significantly. E-seed has an 80% drilling success rate on flat land after 2 rain cycles, making it applicable in a much broader range of environments. Geometry can enhance the functionality of the material beyond what nature offers us. The e-seed carriers are made of paper-thin veneer of white oak, which respond to moisture by swelling. The researchers anticipate adaptation the process to an industrial scale in the future. In addition to seeds, the researchers demonstrate they could use the carriers to deliver nematodes, fertilizer, and fungi. The team developed a 5-step process for manufacturing the seed carriers in the lab, which involves treating the wood through chemical washing and molding the veneer tips on 3-dimension printed mold. This technology was created by a Carnegie Mellon University team led by assistant professor Lining Yao, inspired by the Erodium genius of plants, which has evolved a unique strategy for surviving in arid climate. E-seed is a cutting-edge advancement in seed technology that combines the benefits of self-burying mechanisms with modern engineering. Technology like e-seed can help us address real-world problems, helping us avoid landslides, reducing the impact of invasive species, and improving reforestation of hard-to-reach places. Isn't nature absolutely incredible? Erodium cicutarium self-burying seeds demonstrate the ingenious adaptations plants have developed for survival and propagation.